continue on in lesson 1.4. We still really have the same learning goal, but it's been changed up a little bit. Let's look over here and see. How is this different from yesterday? I can simplify and solve equations in one variable that contain more than one operation. How did that change up today? Shane? Well, didn't you have more than one operation happening in the ones for today? You had to undo addition or subtraction, and then you maybe had to undo division or multiplication. So they already had more than one operation. Thanks for trying. How's that different? I can simplify and solve equations in one variable that contain more than one operation. In other words, what are we going to have to look for today that's going to be a little bit different than yesterday?
I underlined the word and the objective up there.
Simplify. Okay, I even tried to help you guys out. We're going to have to possibly simplify first the one side or the other, or maybe both of the equation before we go about the solving, the undoing process. And this is kind of a big deal that we understand the difference between the two, because students tend to, when they're simplifying, they tend to try to do the same thing twice on the same side of the equation. It's like they're trying to do what we do when we're solving. So we got to make sure that we know the difference between simplifying and solving. So I say here, sometimes you may have to simplify one side or both sides before solving. Simplifying steps actually include combining like terms. So maybe, you know what, let's make the first one, because oftentimes this should probably be the first one you look for. Distributive property. So if there's some distributive property going on in there, some multiplying over a set of parentheses, or in other words, there's a multiplication over addition or subtraction. So in parentheses you have an addition or maybe a subtraction problem going on, and outside that parentheses you have a number that's going to get multiplied times that. Well, because inside those parentheses we're not going to be able to simplify, we use the distributive property to help us simplify. And then the other one is combining like terms, looking for terms that are on the same side that can be put together before you start solving. So sometimes you may have to do both of these things, sometimes you may only have to do one of them, sometimes there may not be any simplifying at all to do. But it's going to be important that we understand, so listen carefully to what I say as we're working. When are we simplifying and when are we actually solving? So here's our first one that we're going to solve. 8x minus 21 minus 5x equals negative 15. Okay, distributive property, if you're going to look for distributive property, that means there would be a set of parentheses in there with some addition or subtraction going on inside the parentheses. Is there?
No.
In this one? No. So no distributive property to do. So the next thing we look for are there any like terms on the same side? Andrew?
8x and 5x.
8x and 5x are like terms. So what we would say is we should be able to put this together with this, right? Those two should be able to be combined. And we have to take the sign that's in front of it so we know how to combine them, correct? So what is 8x take away 5x? 3x, okay? 8 of them, take away 5 of them, you still have x's, now you just have 3 of them. If we bring down the minus 21, that's in between them, because there's nothing on that side to combine the 21 with, is there? No. And then we have equals negative 15. Is there anything on the right side that we can simplify? Anything happening over there? Any like terms over with that negative 15 on that side it can be combined with? No, the only simplifying we can do is that one step of simplifying in this one, and that's combining the like terms of the x's on the left side. So we, right now, all we did was we just simplified. Okay, I want you to put that on that line. This is now simplified. We have not started solving yet. We're getting it ready to solve. We're getting it ready. So now we're ready to solve. And sometimes, I don't know if you done this in the past, it's a good idea to show, you know what, this is what I'm now solving, and I'm going to do the same thing on both sides. Okay? That keeps your work separated. What would be our first move in this one? Jay? Add 21 to both sides. Thank you for saying to both sides. So we now have 3x, these guys are gone, equal to what? What's negative 15 plus 21? Devin? 6. So in other words, I often, when I'm working with positives and negatives, I often think of living in North Dakota. It's 15 below 0 some morning, and the temperature rises 21 degrees throughout the day. Where would it end up at? 6 above 0, right? Okay, what are we going to do next? What are we going to do next? Divide by.
Divide both sides by 3.
Thank you, Andrew. Divide both sides by 3. So x is now by itself, it's a 1x, and x is what? 2. Okay. Okay, we are going to do a check problem. It says in your homework for 24 through 40. So let's practice one right now so that you understand what I mean by checking. Because checking is different than solving. Just like simplifying is different than solving. So is checking. So let's do a check. Whenever you do a check problem, you must check it in the original equation before you did anything to it. You renamed it, whether it was fractions being renamed in common denominators, it's simplifying, whatever. You never check it somewhere along the way where it's shorter so you can create yourself less work. You have to make sure it checks out in the original equation. So we're going to put down our equation, write down the equation, please. Because I'm going to be pretty fussy about these check problems that you understand. They're useless if we don't know how to use them. So every place we see it in x, what are we going to sub in? 2. So we have 8 times 2 minus that 21 minus 5 times 2 equal to negative 15. Now, we are not going to start doing something to both sides of the equation. We're not solving. We're checking. So what we need to do is we need to evaluate that left side of the equation, don't we? We have to follow order of operations and get a value for the left side and hope that in this case it matches the right side. So 8 times 2 is? 16. And then we'll put minus 21. And 5 times 2 is? 10. So again, we're not solving, we're just evaluating right now in our check problem. So let's do 16 minus 21 first. Negative 5. Order of operations says move from left to right when you're subtracting, adding, whatever it is. So negative 5, take away 10 equals negative 15. We're still not done. It is now 5 below 0. The temperature is going to drop another 10 degrees. Where's it at?
Negative 15.
Negative 15. It truly is. Negative 5 take away 10 is truly negative 15. The other side is negative 15. When we have a true statement, a value equal to itself, we can say it checks. Okay? So you have to do check problems for those first problems, 24 through 40, and the evens is what you're doing, of course. Questions? Okay, then let's move on. I'm going to start right now today. I don't think this is ingrained in you yet, and maybe I'm wrong, but when we are simplifying especially, when we have to deal with negatives and subtraction, there's oftentimes trouble. And the reason is because we're not really, most of us are just not really sure how to handle the signage. You know, what's going on here? I got a negative, I got subtraction, I'm really not sure what I'm supposed to do. Or you try something and in the end you'll find out that your answer isn't right. So did you guys change subtraction to add the opposite in junior high math? You're giving me a stare like you have no idea what I'm talking about. Okay, here's what I mean. We are going to do it now. So Here's what I mean. Negative 2 is going to stay negative 2. 3 is going to stay 3. But this subtraction right here is going to become add. And what is the opposite of D? Austin? Or Devin?
Negative D.
Negative D. Now, can you say that you've done that in the past?
Yeah.
Some of us? Do we have all of us yet? Okay, we're gonna probably be more successful if we take the time to change any subtraction to add the opposite, because we're gonna get equations that are gonna get long and complicated. Okay? So, what needs to be done in this one? Distributive property needs to be done. In other words, that negative 2 has to be distributed to the 3, it has to be distributed to the negative D. We have to do 2 multiplications and bring down our addition sign, right? So we're going to do negative 2 times 3, what is that?
Negative 6.
Negative 6. Bring down our addition sign. Negative 2 times negative D.
2D.
Negative times a negative is a
Positive.
positive, and 2 times D is 2D. Yeah. Have we done any solving yet?
No.
We have not. Have we got any more simplifying to do? Are there any like terms to combine anywhere?
No.
No. Remember, like terms have to reside on the same side within an expression. So it's either on the left side of the equation expression or right side. There's some simplifying we can do. So we are ready to solve this one. So we would say, okay, what should we do first? Josh?
Add 6 to both sides.
Add 6 to both sides. So now we have 2D equal to 10. Class, what will we do next?
Divide 2 from both sides.
We divide both sides by 2. Divide both sides by 2. What is D equal? 5. Okay. Let's just do one more check problem, and then we'll not check anymore. But of course, in your homework, you'll write down which ones you have to check. So check. Where are we going to check it at? The negative 6 plus 2D equals 4? Which one?
No, the negative 2, and then in parentheses 3 minus D.
Yeah, we're just exactly where it started. So write down the equation first. Don't sub in right away. Boy, I hate when students do that because I'm like, I'm not even sure that you subbed in right. We go and we look and I'm like, if you'd written down the equation, you could see that, you know what, you missed this part of the equation. So if it's there, now we can just say, okay, I'm going to sub in where the D is 5. And everything you can clearly see that you didn't miss, everything matches up the way it should. Now, again, listen carefully to me. We are basically evaluating. So we're not solving, we don't have to do distributive property. We don't have to do something on both sides of the equation. We follow order of operations. So what does order of operations say to look for first? Parentheses. Well, we got some parentheses, don't we? Okay, so negative 2 times what? What's 3 take away 5? Negative 2. So you could do the distributive property, but you know what? I feel like it might not necessarily go well unless, of course, you changed it to add the opposite, and then you just really kind of create almost an extra step. Now, what's negative times a negative? And 2 times 2? 4. This side becomes 4. I'm not even looking at that side right now. I am evaluating the left side. And after I am done evaluating, now I can say, oh yes, we have a value equal to itself. We have a check. I'm feeling good about my answer. Question? So we're ready to move on to the next one. Okay, let's go. Okay. Go ahead, simplify that left side for me. Let's see how it goes for you. It is simplified, ready to solve. But don't start solving. Just get it ready to solve. When you're done, see if you agree with me, or if you need to challenge me and say, I disagree with you, Mrs. LeGrand. So we're going to take care of distributed property first. Then we're going to look to see if there are any terms that can be combined that are what we call like terms. We can do both this time, right? So any disagreement, anybody? We're all on the same page?
Yes.
Okay, then let's solve it. Go finish solving it now. And instead of doing a check problem this time, if we all get the same answer, we'll feel good. I think Devin's agreeing with me. Are you agreeing with me? We could all be wrong if we got a different answer. You want to challenge us for free. So again, where would, if this was a problem in the homework, where would we do the checking? In the negative 2x plus 4 equals 40. All the way back to the very first beginning. Why is that so important? I mean, there's got to be a reason why I'm making you do it back there. I'm not doing it because I want you to have to work harder. I have to have good reasoning for it. I never make students do something that I don't think is in their best interest. I don't say, oh, you know what, these managers just don't have enough to do. I think I need to make their life miserable. Why would I insist that you do the check problem back in the original equation? Any ideas? Go ahead, Jane. So you don't forget anything. You know what you're evaluating. Okay. What could happen along the way when you're simplifying? What could possibly happen? Could you simplify it incorrectly?
Yeah.
Maybe, yeah. So if you're checking in your simplified equation, in other words, your new name for that equation, if you're checking it in that, is it going to check out? Absolutely, because that's the equation you solved, isn't it? So it should check out in your simplified equation. It should check out there. But then, so you're going to be misled and you're going to think, I got the right answer. And you're going to be like, well, how come I did a check problem, Mrs. LeGrand, but yet you tell me that the answer is not what I got, you say it's something else. And it'll be, if I look at your paper, it's going to be possibly because you didn't check it in the original equation. And when you simplified the original equation, something didn't go quite right, and you have a bad new name for the equation. And of course your answer is going to check out in your new named equation. So I have to have you check it in the original because there's a couple of things that we're really making sure. If it doesn't check out, what should you do? What if your answer doesn't check out? You should what? Pass?
No,
Ask. Or go back and
I agree.
look for mistakes. Look for rework it. Figure out where did it go wrong. It might have gone wrong in the simplifying in the very beginning, or it went wrong in the solving. There's two different possible places it might have not gone so well. So questions. Okay, let's go do one more problem then, and then we can get to work on homework. Write and solve an equation. You're going to have something like this in your homework, so I wanted to practice one with you. Write and solve an equation to find the value of x in the triangle shown. So we have this triangle that has an angle measure of 35 up there at the top, has an angle measure of the bottom right angle is 57 degrees, and the angle in the corner, bottom left corner, is 2x minus 4 degrees. Always make sure you read the question carefully. Are you supposed to find the angle measure that's missing? Because we don't know what the third angle measure is, do we? It's 2x minus 4. We don't know what it is. Or are they asking you to find just the variable? What are they asking us in this one? Devin?
The variable.
The variable. So the first thing I would do is make sure that you pay attention to that. Find the value of x. Because they might, you're going to, and trust me, on a standardized test, like the state test that you take or the math test that you take, when you solve a problem like this, and you get the answer, let's say you get the answer for x, and let's just say it's 20, okay? And you go to the multiple choice answer bank, and you're all excited because there's your 20, you're like, yes, I did it right. But then, in reality, it said find the missing angle measure. That would mean you should sub 20 in for your variable. In this case, let's just use the 2x minus 4. You would have to put 20 in for the x, take 2 times 20, which is
40.
40. Guys, will you stay with me here? Subtract 4, and what do you get?
36.
36. I bet that answer will be in the answer bank too. Which one's right? The 36, because they wanted the missing angle measure. So be careful. Don't always just be so excited that the answer you got is in a multiple choice answer bank. You better make sure you're answering what you were supposed to be finding. Because those people who write those multiple choice answer banks, they're tricky, they're smart, they know what's going to happen, okay? So what is the sum of the angle measures in any triangle? In other words, when you add all three angles up every time, no matter what triangle we are talking about, what should it equal, class? 180. 180 degrees, yes, 180 degrees. That's going to help us set up an equation. Anybody think they have the equation that we can use? Because that's what we're going to do. We're not, it says write and solve an equation. Doesn't say use whatever method you want. It says write and solve an equation. So anybody think they know what kind of an equation we can set up here? AJ?
35 plus 54 parentheses.
I think you mean 57.
57.
Does it have to be in parentheses? Is that what you
No.
Okay. One angle measure plus another angle measure.
Plus, in parentheses, 2x minus 4 equals 180.
Here you go. All three angle measures added together should equal 180 degrees. Now, when there is addition going on, this is kind of important right here. There's addition going on. Sometimes parentheses matter and sometimes they don't. Do these parentheses matter?
No.
When it's addition, they don't. If it was subtraction, that's another story. Okay? So we could really rewrite this as 35 plus 57 plus 2x minus 4 equals 180. Ready to solve? No. We need to do what? Simplify. Now, here's the thing that will happen. Like when I see people simplifying, they will do things like this. They're gonna. What can be put together, by the way, here? Devin?
35 plus 57 minus 1.
Yeah. 35 plus 57 minus 4. So don't write this down, but this is maybe what I would see on some papers. Minus 57 minus 57 minus 57. Does that make sense?
No.
No. So instead, what should we do? Just put them all together, right? Okay, so this is, these guys can be put together with that guy, put together with that guy. So 35 plus 57, who's got that for us? 93. 92. Okay, 92. 92 take away 4.
88.
88. So this becomes 88 plus 2x equals 180. Now, are we ready to solve?
Yes.
Yes. Now we can solve this equation. Go ahead. Find x. It said find the value of x. Find it. When you're done, see if you agree with me. If you don't, either be willing to challenge me or see if you're agreeing with state is. Challenges? Anybody want to challenge this answer? No? Not yet anyway? Okay. Then I want you to work on your homework. Make sure you write down the heading, but then also make sure that you probably make note to yourself somewhere on that assignment, maybe the first line of the assignment. Show check problems 24